Hello and welcome to my short video on my Embedded Systems project. So it's a tilt-based system it's a tilt-based system for a password. So you motion the password in a certain direction and then the accelerometer will send out raw data that will hit certain thresholds to make an LED green when you get them all four of them green. There could be more possibilities, but for this sake, it's just four. Only using the X and Y axis, not the Z axis. You could use the Z axis, but just for simplicity, you can do left, right, forward or back. So it's just kind of a motion you have to make. So I'll just be going over the main code, and then there'll be another part to the video where I actually show the system operating. So the first defined function here is actually the address the STM uses to communicate with the accelerometer, and then you have each sort of function listed here as four possibilities, so you'll need to hit all four of these to unlock the password, or if you don't, then there's this function here which just means nothing happens. The password length is 4. The password timeout is around 5 seconds, so if you don't hit the password in 5 seconds, it'll just reset. Some of the thresholds here they might seem a bit random, but they were like kind of manually gotten when I was testing it using the serial monitor, so they are all actually sort of equal, even though they don't seem equal to each other. So you have the X threshold, which for both directions is 900, so the X it would be left and right, so you have to hit 900 and minus 900. And then the Y is 800 for the forward direction and minus 900 for the back direction. So obviously they're a little bit different, just because the thresholds were a bit unbalanced. Now these sort of functions here are just so there isn't an accidental left or right. So in order for the function, the actual like sort of if this threshold is hit to even be initiated, to check that they would also need to have hit these thresholds here. So, and then obviously all the LEDs are all defined here, as well as the button and the status port. And then so actually this here is for the button status. So if it's red, it'll tell the STM that the system's off, and then if it's green, it'll tell the board that the system is on. This is the timer in milliseconds for the whole system. So some of the other functions will use this to count certain aspects, like how long it takes to complete one password. So that'll be getting 4 functions right. So this function here is for the serial monitor. So basically there's another function here that will show X and Y, but also it'll tell you if X is left, right, forward, or back, or if X is, or it'll say Y. I think they're on the same line, but basically if there's a 0 in here, then it's left. If there's 1, then it's right. Then this here is the locked screen. So okay, this is the function that shows when the screen is, this one here is when the screen is locked. It's just white with a black locked written on it, and then this is when it's unlocked. It's green, and it also has the timer in here, the logic for the timer that will be displayed of how long the system took to, or the password took to complete. Okay, so these are all the for declarations. So any function that's going to be used in the below code will be initialized here. So you have like the tilt detection code, the accelerometer register, some other ones there. I think there's the green LED and the red one, and then also there should be one of these is the timer in its, I think it's this one. And then this is the main this is kind of the function that you can actually change. So if you were to change this to maybe left, you gotta have maybe 2 lefts and whatever. It's just kept this way for now. The password length is obviously 4, that was declared up above. And this is the main section of the code. So it's actually just initializing a bunch of things here, like the raw data for the x-axis and raw data for the y, and then the timer, the buttons, and so on. And then if we get down to tilt lock system, so this is the main logic when the button is pressed, and when the button is not pressed, different things will happen. Obviously, if the button's pressed, then it'll check if system is enabled, then it'll start reading the accelerometer data, sending that out to the serial monitor so you can see it there, and also start the timer, and then it'll reset the timer if you turn it off. So it's just a bunch of if statements. So I realize this video might be getting a bit too long, so pretty much this last section of the code is just housing the main kind of functions and the logic behind those functions. So you're gonna have your password progress and then the tilt detection, so it'll detect obviously like if a tilt occurred, if the tilt's gonna happen, and then how the progress will say yes, it's happened, 1 has happened, 2 has happened, whatever, and then by the time you get all, it should match up, and then you'll get the if statement that houses that will then give you the unlocked, like it says above. So this actually here is the main function for the logic for the actual left and right and backward and forward. So you can see you actually need to hit this here threshold before it even enables you to hit the next threshold. So therefore, it's actually quite efficient in that sense, because you're not accidentally, turning it, and then it's checking that if statement. So it won't check this if statement until you actually turn this to 200. So you would need to actually tilt it, purposely in that direction to activate that if statement. So then you have like the green, the red LEDs, all the logic there. And what is that? The timer's there as well, so they get activated when you press the button. Except for the global one, which is activated anyways. And then you have the static, so this is the accelerometer, ITC, read and write, and all the addresses and stuff. And then this is just more accelerometer reading and writing logic. This is for the monitor, the serial monitoring I'll show you what that does now in a minute. I won't be able to talk though while I'm doing it because I only have one port, so to actually plug in the device I'll need to yeah, I can't talk, but I'll tell you what you should see. So down here you're going to see the X and Y data, and then you'll see if you turn it left, it'll go left and right and back and forward. It'll say, if you press the button, it'll say system is on, system is off, and then you'll see unlocked at the end as well as the accelerometer data. Not the accelerometer data, but you will see that, but you also see the timer. So I will run that now.
Okay, so I'm just gonna demonstrate the board actually working. Okay, so I'm just gonna run the code, or just gonna bin the code. No, okay, run the code. Okay, as you can see, the code is being loaded. So I press this button up here. Now it has initialized the password sequence. As you can see, it is going there, and if I turn it off, it'll actually stop fully. So turn it on, and everything's accelerometer is now sending data to the STM. So then I will do that. So that's left, right, and then either, I think that's down or whatever. That, that, that. Okay, and then forward, I think. Okay, see, now I have gotten a correct password. So now it'll show up here, the time, and it says unlocked now. And then if I press the button again, it'll reset and it'll be locked, and all the LEDs go back to red. And yeah, it'll also come up here as well. If I do it again really quickly, or not. Okay, there we go. And then it says how long it took to do it there. Yeah. So that's pretty much it.